Let's create an Ubuntu server virtual machine in the Amazon Web Services cloud. Now, this will assume that you've already created a Windows Server virtual machine, so the instructions don't have quite as many screenshots here, but we'll walk through it. Step 1, we have to get to the Amazon Web Services Academy Learner Lab course. I'm there, so I'm going to go to the modules and go down to launch the AWS Academy Learner Lab. And once this comes up, I'm going to hit the start button, and that will boot up all my virtual machines that I've got created there already. So start lab. It'll take about a minute, so I'm going to pause the video until it's ready to go. All right, just went green, didn't take too long. I'm going to click that AWS button. That will open up a new tab, and it'll be in the Amazon Web Services Management Console. I'm going to use the EC2 service link here, or you could search for it if you don't have it in recently visited. EC2, we're there. First thing we need to do is create a security group. Security group defines the traffic that is allowed inbound into our virtual machine. So in the EC2 service, I'm going to scroll down past instances, past images, past the Elastic Block Store to security groups. Click that. I've got my default security group. I've also got the security group I created for a Windows server. Now we need one for our Linux server. So I'm going to click Create Security Group. And let's give it a name. Name and description. So I will call this last name. My last name happens to be Markwardson. And I'll name it Markwardson Ubuntu Server SG for security group. And what are we going to do? We're going to call it the description Ubuntu Server. We will allow the secure shell SSH and the Internet Control Message Protocol ICMP. Just those two things. Don't need to touch that VPC. That's good to go. So just taking a look at what rules exist. No inbound rules. That means by default, this is going to block all traffic unless we add rules to let that traffic in. Outbound rules. There is one outbound rule that says let everything out. If it originates from inside that virtual machine, it's allowed to get out. We'll keep that rule there. We're only going to touch the inbound rules. So I'm going to click add rule. The type, we need two things. First, SSH, that's the secure shell. That's what's going to let us actually interact with this virtual machine. So I'll choose SSH. It says the protocol is TCP, that's the transmission control protocol. That's good. And the port is 22. If you remember, in the Windows world, the remote desktop protocol uses a different port 3389. So SSH by default uses port 22. That's what we want. So the source is like, where do we want to allow connections from? We're going to choose anywhere, IP version 4. Anybody across the internet can try to log in, but they won't have the right credentials, so they're going to fail. So that source, it'll fill that in 0.0.0.0/0 is a shortcut for any IP address. So that's good. Description's optional. So let's be lazy and not do it. I'm going to click add rule to add another rule. And here I will choose all ICMP IP version 4. And for the source again, we'll choose anywhere IPv4. So SSH is what's going to allow us to connect and interact, run programs. ICMP, it's just for testing connectivity. We'll learn more about the ping command, which is something that uses this rule right here. If we didn't allow this, we couldn't ping this machine from the internet to test connectivity. So everything's good. Quick review. Markwardson Ubuntu Server SG, Ubuntu Server SSH and ICMP description. Didn't change the VPC. I've got two inbound rules. I'm allowing SSH from anywhere. and I'm allowing all ICMP IPv4 from anywhere. Outbound rules, I didn't touch the one that was already there. It's letting all traffic out. And I'm going to ignore those warnings. They are good warnings, but for our purposes, this is a good balance of usability and security. So I'm going to click Create Security Group, and this goes real quick. It's there. So if I go back, use the breadcrumb navigations, I can look at all my security groups. I've got 3 of them now. The default, my Windows Server Security Group, and my Ubuntu Server Security Group. If you want to check it out, you can click the security group ID. I'll click on the one for my Ubuntu server and show, yep, there's my inbound rules. I'm allowing SSH and all ICMP IP version 4 in. I can click on the outbound rules, and I'm letting all my traffic out. So yeah, this is good to go. Now that we've got our security group created, we can create our EC2 instance, which will be our virtual machine. So I'm going to scroll up in the web console, and let's take a look at instances. Now, when I stopped my lab last time, all my virtual machines, all 1 of them, were put to sleep. So my Markwoodson Windows Server instance is still there, and when I started the lab, it started this one automatically for me. So that's running, it's passed all of its checks, it's good to go, but we're going to ignore that just for right now. We are going to launch a new instance. This will be very similar to what you did for Windows Server. Like with the name, Markwoodson, but instead of Windows, I'm going to call it Ubuntu Server. Now, what operating system do we want? Well, it's going to be an Ubuntu server. And if we look here in the quick start, there's Ubuntu right next to Windows. So I'm going to click Ubuntu. There's a lot of different flavors of Linux. Ubuntu is one that works pretty well in the Amazon cloud. Compatible with a whole lot of software, so we're going to use it. Make sure that we see Ubuntu Server 24.04 LTS. LTS is long-term support, so this can run for a long time, many years. And Canonical, the company that makes the Ubuntu operating system, they're going to issue security patches and make sure it is up to date. So all that's good. So we got the operating system selected, good to go. Instance type, this is the hardware we're going to throw at this thing, and we'll choose that m7a.medium. There's a lot of options here, so I'm going to use the filter up here. Just type m7a.medium. There we go. 1 pretty fast CPU and 4 gigabytes of memory. That's going to be perfect for us. It'll work just fine. So we got our operating system, we got the hardware. Now we're going to configure kind of the software networking. So the key pair, there's only 1 key in the list, so we're going to select it. And just like we did with Windows Server, we're going to click Edit to edit the network settings. We put our Windows Server in the subnet in the US East 1A availability zone. We want to stick our Ubuntu server there. It's gonna make life easier for us. So I will choose the one that says US East 1A. Why is it not in alphabetical order? Well, it's just not. That's life. So I'm gonna make sure you don't pick the first one in the list. Make sure you pick the one that says US East 1A. Every time we boot this up, it's gonna get a new public IP address. That's good. For our firewall security groups, we already made one, so I'm going to select an existing security group. And what is it? It's the Markwoodson Ubuntu Server Security Group. So I will check that, and it will apply it. We do have to expand the advanced network configuration, and we're going to change the primary IP. This will be the private IP address that will it'll be sticky. Every time this boots up, this will be the same. 172.31.16.60. So very similar to our Windows server IP address. The Windows server was 172.31.16.50. So the only difference here is that last number. This one is going to be 60. That's intentional. They're pretty close to each other. Okay. I'm going to keep scrolling down. By default, Amazon doesn't throw a whole lot of storage onto this computer, so we're just going to bump it up. Say, give us 30 gigabytes. So we can add a bunch of files if we need to, install software. Just gives us a little bit of breathing room. So that'll be good. Scroll down even more, expand advanced details, and the identity and access management instance profile. Select that lab instance profile. And that's all we need to change. It'll be good to go. But before I launch that instance, I'll just go through the settings one more time just to make sure everything's good to go. The name, Mark Wordson, I think I spelled my name right. Ubuntu server. You can rename them after you create them, but it's good to have it right the first time. I chose Ubuntu for the operating system, and the specific version is Ubuntu Server 24.04 LTS. That's the long-term support. For the hardware, that's the instance type. I chose m7a.medium. That'll give me one fast AMD CPU. The key pair is that VOC key, the Vocarium key. In the network, we expanded the advanced options. And for the subnet, I chose the availability zone, US East 1A. We chose the option to select an existing security group, Mark Wordson, Ubuntu Server SG. That's good. In the advanced network configuration, we changed the primary IP to 172.31.16.60. I know there's a whole lot of other options there. We can ignore them. We don't need to fiddle with that. Just bumped up the storage to 30 gigabytes. And in the advanced details for the IAM instance profile, we chose the lab instance profile. So this is good. I'm going to click Launch Instance. And fingers crossed, as long as I set everything correctly, I should get this success message here. So I could click on that instance link, but I'm going to go back, use the breadcrumbs to look at all my instances. And where to go? I don't see it. What's wrong? I only see my Windows server. Well, let's go ahead and click that refresh button and it'll show it. All right, I've got Mark Wordson, Ubuntu server. It's running, but it's initializing. It's going to take a minute. So I can't really do anything with it until it passes its checks, showing that it's been created, it's running, it's connected to the network, all of that good stuff. So you can keep clicking that refresh button every minute or so. But for right now, I'm just going to click pause on the video and wait for it to pass its status checks. Okay, it's a couple minutes later and my virtual machine has passed its status checks. That means it's good to go. It's running. Perfect. Now, hopefully you like this next part. Connecting to our Windows server was kind of a pain, to be honest. We had to download a file, then we had to decrypt the password by uploading our private key, doing all that stuff. But because we chose the lab instance profile, there's kind of a little bit of magic that happens to help us connect to this Ubuntu server virtual machine easier. So I'm going to check the box next to my Ubuntu server so that it is selected. It should be the only one selected. And then I'll click Connect. And then it asks, how do I want to connect? There are a few different options. We are going to use the EC2 Instance Connect, and we will connect using the public IP address. The username is Ubuntu. All of this is just perfect. We don't have to change anything. We don't have to download anything. I'm just gonna click connect. And fingers crossed, we will be connected. We are connected. But notice we don't have a graphical user interface. This particular virtual machine just has the command line interface. So we're gonna have to type all of our commands. There's no menus inside this virtual machine. We can't. So we're gonna learn the Linux command line a little bit. So this is looking good. Yeah, you should see this right here. Okay, so we're connected. So what do we actually do with this thing now? We'll learn a lot more about Linux, but here's a tiny little crash course. Let's run some sample commands here. And I'm actually going to move this up so my video camera doesn't get in the way so much. But I'll run pwd, for example, that prints the working directory. That's like, where am I on this computer? Well, I'm in a directory called /home/Ubuntu. If that doesn't mean anything to you right now, don't worry about it. I'll run the command who am I. That tells me what user account I'm currently using to interact with the system, and it tells me I'm using the Ubuntu user account. I can run the ls to list files and directory, and I'll use the option AL to list everything, even the hidden files, in a vertical format. So if none of this output makes sense to you right now, don't worry about it. But I've got a couple of files and folders here. We'll create some files in other lessons. We can navigate the file system. So I would use the cd command to change directories. So if I cd space / and hit enter, my prompt changed ever so slightly. Now if I ls to list the files and directories here, I've got different stuff. So what is all this other stuff? Some of these directories have programs, some of them have hardware devices, some of them have configuration files, a lot of different stuff. If I want to return to my home directory, I can cd space tilde, that's shift and that character right above the tab key. Now if I run pwd again, I'm back in my home directory. So there's some sample output of what you should see, similar to what I just showed. All that's good. Everything's fine. Should be working just fine. And if the Linux commands don't make sense to you right now, don't worry about it. We'll take it step by step. So if we're done, I can just close this tab. Like, I'm sick of Linux. Go away, Linux. I'll just refresh my instances. I could select this Ubuntu server if I want to stop it totally and stop paying that enormous 10 cents per hour to run it. I could go to instance state and stop it. That just puts it to sleep. Any changes I made to that virtual machine will be saved. So if I created any files, they'll still be there when I stop it. And when I start back up again, I can pick up where I left off. So that works just fine. So let's try stopping it, just for funsies. Stop instance. Give me a warning, like, yeah, I'll be charged a couple pennies per month just to store that 30 gigabyte file that we created on Amazon's infrastructure. So it's shutting it down. Soon it'll be unavailable. It is stopping. But I'm going to start it up again, and I'll show you how easy it is to reconnect. Every time we boot this computer up, it's going to get a new public IP address, which was kind of annoying in the Windows world because we had to re-download that remote desktop protocol file. But because of that handy dandy EC2 Instance Connect feature, we don't ever actually have to know what this server's public IP address is. It's taking a minute to stop, which is fine. I'll pause until it's fully stopped. All right, that just took a few more seconds. So it is stopped. So I'm not paying that 10 cents per hour anymore. I've incurred probably 3 cents in charges, maybe, since starting this exercise. So if I check that box, I can go to instance state and start it up. And now it's going to start booting. So if I refresh my status, it says it's running, but it's not ready to connect just yet because it's booting up. It says it's initializing, just going through the startup as if you were booting up your computer after your laptop after shutting it down. So it'll take a minute. So once again, I'll pause the video. All right, took a couple minutes, but my checks passed. It's got a new public IP address. So I can connect to it just how I did before. Check the box next to my Ubuntu server, click connect. EC2 Instance Connect will be the default option. I'll click connect. And I am in like a hacker. Running commands from the command line interface. So if I say, who am I? I am still Ubuntu. All right, so we're back in. So nice and easy. No downloading files, no decrypting passwords or anything. That key, that BOC key that we selected when creating this instance, that's what really gives us permission to log in here. It's securing us. All right, so this is good to go. We don't have to do anything more with this. I'm going to talk just a tiny bit about Linux right now. We're running a version of Linux. There are lots of versions of Linux. Linux is the most popular operating system in the world. Billions of devices run Linux, but most people might not know that they're actually running Linux. For example, if you have an Android phone, Android phones run Linux, but they've got the graphical user interface, all those icons, apps, all that stuff. They try to hide all this command line stuff from you. They don't really want people messing around with the command line interface on your Android phone. Lots of security cameras, Internet of Things devices. If a refrigerator is connected to the internet, it's probably running Linux. Just so many devices run Linux. And we are going to be using Linux from the command line interface, but I'm going to pause the video and just show you real quick that there are versions of Linux that you can get that do come with graphical user interfaces. So I just brought up on my screen a different virtual machine, but this virtual machine is running on my computer. This virtual machine is not running on the Amazon cloud, but the version of Linux I have running on my screen right here, this ethical hacker Kali virtual machine, this is Linux also, but this comes with menus, like it's got a menu like the start menu on Windows, and there's different apps that we can launch. There's a web browser. I can look at the files and folders, so I can open up this interface. I've got some files here on this computer. So it's probably a more familiar interface to many people who are just used to working on Windows or Mac computers. I can bring up a text editor and I can, hello there, I can start creating files using the graphical user interface. I only bring this up to show you that I don't want to bias you against Linux. If you're not a huge fan of the command line interface, there are versions of Linux that do come with graphical user interfaces. But for now, we're good. Our virtual machine, our Ubuntu server virtual machine is good to go, ready for the other labs in class. You do not have to create your own Kali Linux graphical user interface virtual machine on your computer. I just wanted to show that just to give a little bit of perspective. So we're good to go. If you're all done for today, you can just come back to the AWS Academy. If you end your lab, it'll shut down both of our EC2 instances. For example, if I come back to my EC2 instance connect window, it'll disconnect me because this virtual machine is going to be shutting down, so it's going to kick me off. If I look at my list of instances, it'll show that they are in the stopping state. They're not stopped yet, but they are stopping. They're trying to shut down. So if we go to that EC2 instance connect window, eventually, yeah, it says the system will power off now, exclamation point. So that's perfectly fine. I'll just close that tab. Done with that. I'm done with the Amazon Web Services Management Console, so I can close that tab. My lab's shut down, so I'm going to stop those per hour charges for running those EC2 instances. All right, now that that's ready to go, we will be diving into Linux a little bit more. We'll be running a lot of commands, learning how to navigate the file system, use different Linux programs. And so if some of those commands and that command line interface felt uncomfortable, don't worry. We're going to learn it step by step.